In this video, we're going to define acid and base based on three different acid and base definition. The very first one is the Arrhenius acid and base. And so what is that? Arrhenius acid and base refers to, for acids, it produces hydrogen or hydronium atom, also known as protons, if that particular substance is submerged into water. For example, here's HCl. This is an acid because when submerged in water, or maybe perhaps react with something else, it's going to produce H+. You see that H+ splitting from the HCl. Also, you might have noticed in many of the chemistry classes that it forms H3O plus, and that's hydronium ion. And this is only because the H plus reacted with the water to form hydronium ion. So we say that it forms H plus, it's the same as H3O plus. Also, we say that it's also known as protons. That's because H plus, by its component, if you look at the particles, the atom particle, it just has proton, no electrons, just a proton. And so therefore it's a positive charge, hence the name proton. So again, Arrhenius acid says that it's going to produce H+, and that makes it an acid. Something that is base will produce OH- ions. So for example, sodium hydroxide, when submerged in water, it splits off into sodium and hydroxide ion. Now let's look at the definition for Bronsted acid and base. And this one says, hey, it's an acid is a compound that donates, or also known as the protons, donates the H+. So here's your acid and here's your base, and you see the base accepting the H and the H donating it to here. So if you look at the definition on the left and the right, it shows that for acid here, it's donating, it's giving it away H. Over here, it just says it produces. So it's just a little more advanced definition. Even the base, it's a compound that accepts the H+. It's not no longer just it has OH-, but it's a compound that accepts the H+. All right, so let's look at the very last acid and base definition, which is the Lewis acid base. Here, now it doesn't involve anything to do with hydrogen for acid, but it says that acids are electron acceptors. They're going to accept an electron. So if you look at this right here, this water and BF3, this B is going to accept the electron from the oxygen, and you see how there's an arrow showing that there's going to be a bond, and there is that covalent bond sharing of the electrons because the acid has accepted those electrons on the pair of electron from the base. So the base, therefore, it has nothing to do with hydroxide, nor has anything to do with H+, but rather it has the ability to donate an electron. So you see this base donating its electron to the acid. So you can see how all of these three definitions are different, and they do go in more advanced, and the Lewis acid and base would be the more advanced definition of acid and base.